All right, we want to come up with a factoring strategy to factor polynomials, but we just want to realize that factoring is the same as expanding backwards. So if we were to take this expression and expand it, this is in factored form. So this is just one term with a monomial factor and some binomial factors. So this is in factored form. And if I expand it, I can only multiply two factors at a time. So which two do you want to start with? Well, if I notice here we have conjugate factors, so if I start expanding, maybe I'll multiply that one first, and we'd get a factor of x squared minus 9. Now, the other factors, basically I need to keep track of. And again, we're expanding. So now, maybe I'll multiply the two binomial factors together. And again, I'd have to distribute term by term. And then collect like terms. I would end up with an x cubed plus 4x squared minus 9x minus 36. Now that factor still needs to be multiplied by this negative 2x. The negative 2x is distributed term by term, so I'm going to end up with a negative 2x to the fourth minus 8x cubed plus 18x squared, and then I'd have plus 72x. So this expression is now in expanded form. So if we think about how we factor, we want to take the expanded form, sorry about that. We want to take the expanded form and write it back in factored form. So how do we start? Well, we basically start just like we expanded. We want to start backwards. The first thing we're going to look for is a greatest common factor in all the terms. And if we do that, we're going to end up with this next row. Negative 2x is the greatest common factor, and then I'll end up with this x cubed, or this 4 terms. So can I continue to factor? Well, for this one, I can continue to factor in the parentheses. This is 4 terms, so maybe do factor by grouping. To get me to the next level. So when I factor by grouping, I end up with this expression. And now I recognize that x squared minus 9 is a difference of squares, and I can factor that into two conjugate factors. So it's basically just factoring is the same as expanding backwards. So I just want to generalize this into a strategy, basically. A couple of things is, first of all, we want to use the number of terms. We're going to use the number of terms in the expression to determine the type of factors to look for, or factoring strategy to use. So the number of terms is going to be the indicator. And the other thing that I like to think of is look for the easiest to recognize factors first. So when I'm factoring a polynomial, the easiest ones to recognize, I want to do those first. So the first step we should do is look for a greatest common factor in all the terms. So look at the whole expression. Is there a greatest common factor? So we will do that. Now if there's 4 terms and there's no greatest common factor, we're going to try factor by grouping. So factor by grouping allows us to look at those 4 terms as two sets of 2, right? Now, so far, these are the easiest methods to use. If we are looking, then the next easiest factors, the nice binomial factors, I want to look for, and if I have 2 terms, I want to look for a difference of squares, because if there's two terms, the only thing I can try are these conjugate factors. So if I have a difference of squares, then I know that it factors to conjugate factors, a plus b, a minus b. If there's three terms, at least we can do is look for binomial squared factors. So this is binomials, or a binomial squared factor. So how do you look for, if I have a perfect square trinomial, then I'm looking to whole factors to binomial squareds. And the last thing, if those should be the easiest factors to look for, but if I have three terms, if I have a trinomial, look for binomial factors using the trial and check method. So the trial and check method is kind of a last resort. And then step 5, we want to make sure that we factor completely. And that just means that continue to factor any group factors if possible. So to factor completely, we kind of showed you in that first example. So I'm just going to go back up and then I'll generalize this again. So when we start factoring the greatest common factor, we notice that the expression here can be factored further. This is a group factor that can be factored further. So then we have another factor, x squared minus 9, that can be factored further. And so when we're done factoring, this is completely factored. So let's just go through the strategy again. Again, the idea is that we want to use the number of terms to determine what we're looking for, types of factors in a factoring strategy, and then look for the easiest factors first. So again, the easiest factors, greatest common factor, looking at all the terms. If there's 4 terms, factor by grouping, really the only thing we can do. Then look for binomial factors that are nice. So look for conjugate factors and look for binomial squared factors. And then finally, if there's 3 terms, we want to look for binomial factors using that trial and check method. Okay, so we're going to use that strategy on the next video, and we'll go through a bunch of examples.